Hello everyone and welcome back to CAQM Compliance Explained. In our previous episode, we have discussed several APCD technologies for the industries utilizing boilers and furnaces. And we have learned that there is no universally best technology for mitigating your particulate matter. Each APCD has their own sets of advantages and disadvantages. Yet, if there is any technology which attracts more discussion and debates is Electrostatic Precipitator or simply ESP. We have approached several boiler manufacturers, consultants and boiler operators and heard completely different opinions. Some told that ESP is the most efficient technology for reduction of particulate matter, while others claimed that ESP cannot be used for the biomass based boilers. Some have claimed that ESP uses enormous amount of energy in the form of electricity, while some have claimed that it is inefficient for the smaller particulate matter. So what should industries believe on these claims? Should we accept or reject? So instead of accepting or rejecting this claim, let's analyze these claims from the engineering perspective. The first and perhaps most common myth is ESP explodes if water enters. This belief is believable because ESP uses high voltage corona discharge and naturally people associated electricity and water with danger. If an electrostatic precipitator operates at high voltage and uncontrollable water enters to the electrical component, that can cause flashover, insulator failure, equipment damage and many other issues. But this doesn't mean that the ESP itself will explode automatically. In fact, many electrostatic precipitators such as weight ESPs are developed for operating with water. So the engineering question isn't about whether water explodes my ESP or not. It should be how much amount of water is present and is my system designed to handle that particular operating conditions. Let's look at another common statement. An ESP cannot work on the biomass boilers. Biomass is certainly more challenging than the conventional fuels due to the fuel variabilities. These fuel variabilities include wooden chip, rice husk, briquettes and other biomass based fuels. All these fuels produces ash which is having different characteristics. These fuel variabilities influences the ESP performance and makes engineering more difficult but not impossible. In fact, around the world, many ESPs are successfully operated on the biomass based boiler from the decades. The success depends on understanding the fuel before designing the system, not avoiding the biomass altogether. The next myth is moisture is bad for ESP. This statement sounds logical, but engineering is rarely that simple. Too much uncontrollable moisture can create operational problems. But moisture also changes particle resistivity and electrical charging properties. Under some conditions, controlled moistures in fact can improve the ESP efficiency. Like many other engineering properties, moisture is neither good or not bad for the system. Its effect entirely depends on application and engineering design. Now let's discuss another statement: an ESP cannot collect fine particles. This misconception comes from imagining ESP as a mechanical filter. But ESP works differently. Instead of trapping particles, it charges them electrically and attracted towards the collecting electrodes. The collection efficiency depends on electric field, residence time, gas velocity, surface area available and many other engineering properties, not simply on the particle size. When properly designed, ESPs can achieve exceptional collection efficiencies for the fine particles up to the nanometer scale. The another statement frequently heard is an ESP consumes enormous amount of electricity. High voltage often sounds frightening. People hear 50,000 volts and start imagining huge electricity bills. An ESP operates at high voltage but relatively lower current consumption. So its electrical consumption is often much lower than what people expect. In fact, in many installations we have observed that the power required to overcome the pressure drop is much more than the electrostatic precipitator usage. Now moving ahead with our next myth: back filters are always better than ESP. So as we earlier said that no ESP technology is universally best, and each technology has their own sets of advantages and disadvantages. So what is the truth? Is ESP better or the baghouse? The truth is that the question in itself is wrong. Bag filter performs exceptionally well in many industrial applications. On the other hand, ESP also performs exceptionally well in other applications. The technology selection is based on several engineering properties of your system, such as dust properties, gas temperature, moisture, operating philosophy, maintenance capabilities, life cycle cost, available space, and emission limit that you have to achieve, and etc. etc. So the choice is entirely depending on the parameters that you have set for the selection of the technology. The better question is not which technology is better. The better question is which technology is best suited for my application. That is how every engineer approaches to the design decision. Not through assumptions, not through marketing claim, and certainly not through whatever the myth they have heard from the decades. Engineering is about understanding the system, evaluating the evidences, and selecting the right system for the right conditions. So today's discussion shows that the myths in the industries begin with the real experiences and then later generalized. Good engineering replaces assumptions with evidence. Before accepting any statement about APCD, ask these 3 questions to yourself. Why do people believe it? What does engineering actually say? And under what condition that statement is true? Because in engineering, context matters. But this naturally raises to the another question: how does electrostatic precipitator actually works? What exactly happens inside the electrostatic precipitator? And how does the particle get charged and captured on their surfaces? But that's the question for the next episode. Stay tuned and stay connected. Thanks for watching.